Hello, in this video I'm going to share some details about the folded dipole antenna. So this is the structure of a folded dipole antenna. Before going to the details of the folded dipole, let's see some characteristics of a dipole antenna which was discussed in our previous videos. In case of a dipole antenna, we know that the total length of the antenna will be approximately equal to the half wavelength, and based on the material that is used for creating this half wave dipole, the length will be little bit less than the half wavelength, and the radiation resistance of these dipole antenna is around 73 ohm, and directivity of the half wave dipole is 2.15 dBi. It has an omnidirectional pattern, and if you have to design a dipole antenna at some frequency like 2.45 gigahertz, you have to find out the length of the antenna and this radius of the antenna and gap between the elements. This radius of the antenna has some influence on the bandwidth. So here one of the characteristics that we have to consider is the radiation resistance is around 73 ohm. Let's go into the folded dipole antenna. So in earlier days when we are connecting the TV, we are using tin wire antennas. Here you can see that two wires separated by some distances. So in this case of these twin wires, it has an impedance of 300 ohm. Here you can see the impedance of twin wires is 300 ohm. These wires were usually used to connect the TV antennas before the use of our dish antennas, because previously we were using Yagi Uda antennas for the TV communications, right? So at that time, if we want to have some communication, means some connection with the dipole antenna, because the dipole antenna impedance is 73 ohm and the thin wire cable has an impedance of 300 ohm, it is not possible to connect the dipole antenna to the thin wire antenna. So to use some antenna having the impedance approximately equal to the 300 ohm, these type of folded dipole antennas were uh, invented. So in case of the folded dipole antenna, the impedance of the folded dipole antenna is approximately equal to 300 ohm. That is the main characteristics of the folded dipole antenna. Let's see the more details. In case of a folded dipole antenna, here you can see that it consists of two dipoles which is separated by a gap of S, and the length of each dipole is approximately equal to 0.5 lambda. Here you can see that this length is approximately 0.5 and the total length of this is also 0.5, and each arm will be around 0.25 lambda. And we know that in practical cases it is not possible to bend the wires like this 90-degree bend. So in actual cases it will be looking like these type of bends. So here you can see that how the bend is happening, like it is not like a 90-degree bend like this, it is like some curved bends. So this is a folded dipole antenna. So here we have a fold of two. That means that there are two half wave dipoles separated by a distance S. And the characteristics of S is it should be less than 0.05 lambda, because we are maintaining this separation as less than 0.5 lambda to have some coupling effect between these two wires. Let's see that in more details while discussing about the impedance. So if you are considering a dipole antenna, this is the structure of the dipole antenna. It has two modes of operation. First one is transmission line mode and second one is antenna mode. In case of the transmission line mode, we are giving the feed in between here for means for the folded dipole case, we are giving the feed like here. And in case of the transmission line mode, the current which will be flow continuously in between these two wires like this. That is, it is acting as a transmission line. But in case of antenna mode, here you can see that the current direction is same in this direction. Both are in the same direction. These type of antenna mode occurs because of the coupling between these two conductors. So in case of the transmission line mode, as the current is means getting cancelled, there is no in effect radiation. But in case of the antenna mode, as the current is both in the same direction, it will be excited both like this. So it will be the current distribution like this, and it will in effect give for the radiation. So the total impedance of the folded dipole antenna can be given by V by In. In is due to the sum of both this current IT and IA by 2. So based on that, we can calculate the total impedance R for ZT into ZT by 2ZD plus ZT. ZT is the impedance due to the transmission line mode, and ZD is the impedance due to the antenna mode. Here D is given as this antenna is like a dipole antenna. Here you can see that these two will be acting as two dipoles. So the current distributions will be like this. That is antenna mode impedance is given as ZT. So we know that the impedance of dipole antenna is 73 ohm, that we have discussed earlier. So here you can see that the dipole antenna has an impedance of 73 ohm. So here ZD is 73 ohm. So in this case, we can also calculate the transmission line impedance using our formula like Zn equal to Z0 plus Z del tan beta L, that equation. And if we approximate that, you will get the input impedance as 4ZD. So the total impedance can be given by 4 into 73. It is equal to 292 ohm. So that means that the impedance of the folded dipole antenna is approximately matching to these tin wire cables. That is the importance of folded dipole antenna in communications. So in general case, if we are considering a folded dipole antenna, the total impedance, if let's consider if we have a dipole antenna having n number of folds like this, the total input impedance can be given by n square into ZC. N is the number of folds. So in case of a two element, that is these two element cases, the total input impedance can be given by 4 into 73. Sorry, this is n square into 73. So 4 into 73, which will be approximately 300 ohm. So based on the number of elements used in the folded dipole, we can calculate the total input impedance. So make sure that this is the input impedance based on the number of foldings. And the main characteristics of this folded dipole antenna is that it also has the radiation pattern like an omnidirectional pattern, same as the dipole antenna. In effect, folded dipole antenna is like a dipole antenna, like two dipole, and we may be consider it as two dipole antennas together. So this is a comparison between the half wave dipole and the folded dipole. In case of the uh, half wave dipole antenna, you can see that it is a single conductor which has a split in between them for the feeding. In case of the folded dipole, it actually consists of two dipoles and which is separated by the narrow loop, and it has a feed in between on one section. And in this case, the total input impedance is 73 ohm for a half folded dipole with two elements. The impedance is 300 ohm. And the bandwidth of this folded dipole is little bit wider as compared to the dipole antenna. And the impedance calculation for the half wave dipole is always 73 ohm, and in case of the folded dipole, it can be calculated by n square times 73 ohm. N is the total number of elements used. And for this half wave dipole, we are using 75 ohm coaxial cables, and for folded dipole, we usually use 300 ohm tin lead transmission lines. So I hope you get some idea about folded dipole antennas, and thank you so much for listening.